Ever pondered the question, is AGI already here or will it happen soon? Well, you're not alone. As we stand at the brink of a technological revolution, AGI, or artificial general intelligence, is a hot topic that's stirring up a storm. Imagine a machine that can understand or learn anything that a human being can. Yes, you heard it right, anything. That's the promise of AGI. Now let's talk about OpenAI. It's a name that's been making waves in the field of AGI. They're leading the charge, pushing the boundaries of what's possible and cooking up something that could change the world as we know it. But what goes into this recipe of AGI? What are the ingredients that might bring this extraordinary feat of engineering to life? Firstly, we need a deep understanding of the physical world, a digital realm that can simulate our own. This is the canvas on which AGI paints its masterpiece. Then comes the ability to see, hear, and communicate, to perceive the world as we do and interact with it in a meaningful way. Next on the list are autonomous AI agents, independent entities capable of making decisions and taking actions without human intervention. And of course, we can't forget about the AI chips, the beating heart of AGI, powering these intelligent machines. Throw in abilities like music and sound generation, and you've got a machine that not only thinks like a human, but can also create like one. Combine all these ingredients together, and what do you get? A machine capable of performing most human jobs, an early version of AGI. But how close are we to achieving this? And more importantly, is it safe? Please subscribe and let's dive into these ingredients one by one and see how close we are to cooking up AGI. The first ingredient towards AGI is understanding the physical world. Now you might be wondering, why is that so important? Well, for an AI to truly mimic the human mind, it needs to comprehend the world we live in, just like us. Enter OpenAI's Sora, a video generation model. But Sora is no ordinary model. It's designed to serve as a simulator of the physical world. Picture this. Instead of just generating random videos, Sora is trained to understand and replicate the physical laws that govern our world. It's like having a mini universe inside a computer. Now, why is this significant? Because it's a stepping stone towards creating an AI that can interact with and understand the world as we do. Imagine an AI that can predict weather patterns or understand the physics behind a ball's trajectory. That's the kind of understanding we're talking about. But it's not just about understanding. It's also about learning. Sora and models like it are designed to learn from the data they're fed, to refine their understanding of the world and improve their predictions. It's this ability to learn and adapt that brings us closer to AGI. So where does this leave us? OpenAI's work with Sora shows that we're making strides towards simulating the physical world, a crucial ingredient in the recipe for AGI. But remember, this is just the first piece of the puzzle. There are many more ingredients to discuss, and we'll be exploring those in the upcoming scenes. So, we see that OpenAI has begun simulating the physical world, an essential step towards AGI. The next ingredient required for AGI is the ability to communicate. Just like humans, an AI with aspirations of matching human intelligence needs to be able to interact with the world around it. This interaction isn't just about understanding and processing information, but also being able to convey thoughts, ideas, and responses. This is where OpenAI's ChatGPT comes into play. ChatGPT is a language model developed by OpenAI. It's designed to generate human-like text based on the input it's given. But it's not just about spitting out text in response to prompts. ChatGPT has been trained on a diverse range of internet text. But what sets it apart is its ability to understand context, respond appropriately, and even exhibit a sense of wit and humor. It's like having a conversation with a well-informed, quick-witted friend. Now, why is this important for AGI? Well, communication is a cornerstone of intelligence. It's how we share ideas, solve problems, and connect with each other. For an AI to truly match human intelligence, it needs to be able to do the same. It needs to not just process information, but also communicate its understanding in a way that's relatable and understandable to humans. With ChatGPT, OpenAI has given their AI a voice. It's a voice that can answer your questions, write essays, tutor in a variety of subjects, translate languages, and even generate creative content like poetry and stories. But more importantly, it's a voice that understands and communicates in a way that's distinctly human. So we have another ingredient in our AGI recipe. OpenAI has thus given their AI the ability to communicate, another key ingredient. But as we'll see in the next scene, there's more to AGI than just seeing, understanding, and speaking. Now that you have subscribed and liked the video, let's look at the third ingredient. Autonomous AI agents. These are artificial intelligence systems that can perform tasks independently, without the need for human intervention. Think of a self-driving car navigating traffic or a robotic vacuum cleaner tidying up your living room. These agents use AI to perceive their environment, make decisions, and execute actions all on their own. OpenAI is making significant progress in this field. Autonomous AI agents are a key element of their vision for AGI. They're not just focused on creating AI that can understand and interact with the world, they're also building AI that can act independently within it. Consider OpenAI's work with reinforcement learning, a type of machine learning where an AI agent learns to make decisions by performing actions and receiving feedback. This learning method allows the AI agent to autonomously improve its performance over time, without being explicitly programmed to do so. OpenAI is applying this technique to a variety of tasks, from playing video games to controlling robotic hands. In each case, the AI agent learns to perform complex tasks independently, becoming more proficient with each attempt. But it's not just about individual tasks. OpenAI is also working on multi-agent systems, where multiple AI agents interact and learn from each other. This could lead to more sophisticated AI behaviors and capabilities, as the agents collectively learn to solve complex problems. OpenAI's work with autonomous AI agents is a crucial part of their overall strategy. By developing AI that can operate independently, they're bringing us closer to a future where AI can perform a wide range of tasks, from driving our cars to managing our schedules without needing constant human supervision. OpenAI is thus making strides in creating autonomous AI agents, another essential component of AGI. The next ingredient in our AGI recipe is a massive amount of AI chips. Now, you might be wondering, what exactly are these AI chips we're talking about? Well, in simple terms, AI chips are specialized pieces of hardware like GPUs, graphics processing units, and TPUs, tensor processing units. These chips are designed to efficiently handle the heavy computational requirements of training AI models and running inference. Think of these chips as the powerhouse that fuels the brain of AI. Without them, the sophisticated AI models we have today would take an exorbitant amount of time to learn, process, and deliver results. In a recent turn of events, OpenAI CEO Sam Altman has sought approval for an AI chip venture, eyeing a staggering $7 trillion in funding. This venture aims to build the infrastructure needed to produce these AI chips at scale. But why is this funding and infrastructure so important, you might ask? Well, it's all about scalability. To enhance the capabilities of AI models like Sora, for instance, we need to scale them up. Scaling is the process of increasing the size and complexity of an AI model to improve its performance. Take Sora, for example. OpenAI has shown that scaling Sora from a basic model to computed 4 times and 10 times can significantly enhance the quality of the videos it generates. This means that with more powerful AI chips and the right infrastructure, we could potentially generate even more convincing simulations of the physical world. Now imagine the possibilities if we could scale up not just Sora, but all AI models. We could achieve more accurate predictions, faster processing times, and even more human-like AI. And that's exactly what OpenAI aims to do with its proposed AI chip venture. With a potential AI chip venture on the horizon, OpenAI continues to gather the ingredients for AGI. The next key ingredient is the ability to generate music and sounds. As we journey further into the realm of artificial general intelligence, we find ourselves exploring the auditory domain. OpenAI is currently working on models capable of generating music and sounds, a critical component in the AGI puzzle. Why is sound generation important, you ask? Well, sound and music are integral parts of human communication and expression. From the rhythm of speech to the melodies of music, they evoke emotions, convey messages, and create shared experiences. If an AI is to understand and interact with us at a human-like level, it must be able to comprehend and generate our auditory language. But it's not just about understanding and creating music or mimicking the sounds of nature. It's about the AI's ability to interpret and respond to auditory data in real time. Imagine a machine that can listen to a piece of music and generate a completely new composition in response, or an AI that can replicate the exact tone and inflection of human speech. This capability could revolutionize the way we interact with AI, opening up new avenues for creativity and collaboration. OpenAI's work in this area is ongoing. They are refining their models, pushing the boundaries of what's possible in sound generation. Each step they take brings us closer to an AI that can truly understand and emulate the richness of our auditory world. And it's not just about the bigger picture of AGI. Practical applications of these sound generation models are vast, ranging from creating original music and sound effects for films, to developing more natural-sounding voice assistants, to aiding in auditory research. However, like all aspects of AGI development, the path is complex. Issues such as how to ensure the AI's creations are original and not simply reproductions of existing works, or how to navigate the ethical implications of AI-generated music, are challenges that need to be addressed. But one thing is certain. With each note they simulate, with each sound they generate, OpenAI is turning up the volume on the march towards AGI. With sound generation on their roadmap, OpenAI continues to prepare for AGI. Combine everything together and we have a recipe for AGI. We've walked through the various ingredients that make up artificial general intelligence. The understanding of the physical world, the ability to see, hear, and communicate, autonomous AI agents, a search engine-like capability, a massive amount of AI chips for training and inference, and the ability to generate music and sounds. Each of these components represents a piece of the AGI puzzle, and OpenAI seems to be diligently putting those pieces together. The recent introduction of Sora, a video generation model that acts as a simulator of the physical world, is a testament to their progress. But it's not just about the individual components. It's about how these components work together, creating a system that can learn, adapt, and operate with a level of autonomy that mirrors human intelligence. Now let's stir the pot with some rumors and developments. The recent firing of OpenAI's CEO, Sam Altman, and the introduction of Sora on a platform typically reserved for major releases suggests something is cooking. There are whispers about a project codenamed Q-Star, hinting at something even bigger than Sora. It's like a chef teasing us with a whiff of a secret ingredient. And then there's the scale. OpenAI has been scaling up their models, improving their efficiency and capabilities. The scaling of Sora, for instance, has significantly enhanced the quality of the video it generates. It's like watching a chef refine a recipe, tweaking the ingredients, and adjusting the cooking time until the dish is just right. And in the world of AI, just right means safe, efficient, and capable of performing most human jobs. So, while we can't peek into the OpenAI kitchen, we can certainly smell what's cooking. And it smells a lot like AGI. With these ingredients, it seems OpenAI is not only cooking up AGI, but perhaps they've already had a taste. So have we already achieved AGI, or is it just around the corner? As we wrap up our exploration, let's revisit the key points. OpenAI's advancements in understanding the physical world, communication, and autonomous AI agents indicate we're on the precipice of a breakthrough. Add to this the development of AI chip infrastructure and the creation of a music and sound generator, and it appears we're inching closer to AGI each day. Yet, are these advancements enough to claim we've reached AGI, or are they mere stepping stones on a much longer journey? The drama surrounding OpenAI, with rumors swirling and high-stakes decisions being made, suggests something big is brewing. But what that something is, only time will tell. We invite you to join this riveting conversation. What are your thoughts on AGI? Is it already here, just around the corner, or a distant dream? Or perhaps you believe AGI is a concept that will never fully materialize. Whether AGI is here, imminent, or a distant dream, the conversation around it is certainly fascinating. Until next time, keep questioning, keep exploring, and stay curious.